Okay, a little addendum. If you have three equations and three unknowns and the augmented matrix reduces to this, which might happen, what's that mean? Well, first place in terms of the equation, it means you got 0 equals 0 for two of your equations, and your first equation is just what you get. In this case, well, there it is. I don't have to read it to you. So you have this equation. Okay, well, that means all your solutions are in the same plane because 4 plus x plus 4y minus 7z equals 3 is a plane within three-dimensional space. We haven't proven that, haven't shown you how to graph it or anything, but you can kind of understand that and accept it by an analogy, say, to the way a line is a one-dimensional subspace in two-dimensional space, right? And you saw in class situations where you had a 0 equals 0 solution to two simultaneous equations and two unknowns, and that gave you a line, and every point on the line was a solution. Okay, so I say all the same plane. And I'll use R, but all three equations correspond to the same plane. And this is the plane. This equation gives you the plane. Okay? Now, this means that we don't have any restriction on two of our variables, and that the third variable then depends on those two. So, for example, if we wanted to choose x and y as being free variables, then z could be expressed in terms of x and y, and we could plug any numbers x and y into a point and get coordinates of a point on the plane, an x, y, and a z that satisfy all three of the original equations. Now, to be more explicit, let's say we've got two free variables. Let's just say we chose y and z to be the three variables. I could choose any two. Choose x and y, we could choose x and z, we could choose y and z. We choose any two of the three variables as free variables. Let's see what this means. Okay, so if we let y and z be the free variables, then we'll express x in terms of y and z. So y and z are free, meaning they can take any value. That's what free variable means. And once these take that value, then this equation tells you what x has to be. So our plane could be described like this. The set of all points, 3 minus 4y plus 7z, which is just what x is equal to, and then yz, where y is any number and z is any number. That means y is in the set of real numbers. That means y is a real number, z is in the set of real numbers. This means z is a real number. You choose any two real numbers, and you only need to choose two, and everything is determined. All the coordinates of this point are determined. Okay? So, and that's what I say here, put in any y and any z, you get three coordinates here. And those three coordinates will solve any of the three original equations. They'll solve every one of the three original equations. Okay, since there are two parameters here, two free parameters, that means you've got a two-dimensional solution in three-dimensional space. You won't totally understand that now, but we want to get the idea of smaller spaces and bigger spaces. Now, having said that, this isn't a space. It's what we call an affine plane, but we'll make that distinction later. It's still something of two dimensions. It's a two-dimensional plane within three-dimensional space. And I'll just say what we call a subspace would be a two-dimensional plane, a plane that goes through the origin. And that's a concept that will take a little while to develop.